maybe we start off here. Maria, maybe tell us about all the projects which you've been doing with DCIT and with all the funding which has been going your way.
A lot. Thank you very much for that. We wouldn't have a company if it wasn't for it, I can tell you that. So we've been part in early days, we were part of the 5G Create, very much trying to put everything in order, so software in servers. Pretty much it. We work with Arnaud in that one. Then the second one was the Oranos project which we did with Dimitra's team in Smart Internet Lab, also with Cellnex, Parallel Wireless, who were around here. So that was a really cool project where we actually first introduced the gathering of data and delivering some form of intelligence with the satellite applications catapult, kind of like selecting a backhaul solution based on that. So University of Bristol delivered that solution. And now we are part of the Reason project, which has an entire work package looking at AI and data acquisition and delivery. A lot of the learnings are being applied there as well. And we have a lot of very intelligent people looking at solving very challenging problems, introducing AI networks. And also now we're part of the Liverpool project where we are using the RIC, again, with XRN, and delivering some sort of intelligence in the form of XR apps, leveraging the new interfaces. So a lot.
Perfect. So any guesses from anyone on who named Oranos in this room?
You?
That wasn't me. Yeah.
There's a lady sat out there who was...
You're very good with names, actually. Yeah.
Greek name, so that could only be coming from one single place.
It's sky, right?
It's the sky in Greek, for those who don't know. Arnold, come on, let's hear from you about what Acceleron are doing.
Yes, I think Maria has already summarized a few projects that we've done together, and I think we also have a long history from an Acceleron perspective of working with DCIT, and we've been lucky enough to also leverage the funding coming our way to accelerate the development, especially of our RIC platform, so the RAN Intelligent Controller. I think just to zoom out a bit, obviously we've been saying this morning that AI was quite meaningful in the context of wireless, but I think one of the key enabler for us in wireless is also Open RAN, right? And when you look at Acceleron, we are an Open RAN software innovator. We develop our RIC platform, and this RAN Intelligent Controller really is the platform that allows developers to leverage the open data and the open controls that Open RAN is going to put in the hands of innovators. So in the context of DCIT projects, most recently, we've been involved in ARI 5G. ARI standing for Accelerating RAN Intelligence, and obviously we like acronyms, as you know. But concretely, I think that was let's say a key project to showcase the benefit of an Open RAN architecture in the context of enabling AI for telecom. Because in that project, we show multiple things, but the two key takeaways is that, first of all, we were able to demonstrate that when you put an open platform in the hands of developers, they can come to very quick, tangible results in terms of using AI for specific use cases. I'm not going to get into the details, but we've been tackling things like energy saving, we've been tackling capacity and coverage optimization, massive MIMO optimization. And the second thing is that in terms of showcasing and proof point is that we've not only done that on simulator and on simulated data, because I think the risk also of AI in telecom is that it remains a very theoretical perspective, but we've taken that to the next step, right? I mean, we've been doing app development on simulators that our friends from Viavi have contributed to the project. But next to that, we've also pulled together a real 5G SA test bed in an Open RAN architecture, meaning a CU, DU, RU, totally disaggregated and exposing data to our RIC platform, where we've been able to showcase the concrete and tangible result of these apps being developed. So I think, to me, that's really an acceleration of RAN intelligence in 5G, right? It's not only staying in a lab, and all due respect to, we need to go through the lab, but to show the whole process of application development and AI enablement for telecom. Okay, so that's been to me the two key takeaways of this RE5G project that we've done with DCIT.
Sounds good. And do you also want to tell a little bit about some of the work you've done with the digital catapult?
Yes, no, absolutely. I think thanks for that. I think yes, we've done also some very interesting work with digital catapult, and thanks Dritan for making that happen, right? In two ways, right? First of all, in the Sonic Labs, which I think is a great playground for the Open RAN community to come and show interoperability and to showcase how data can be exposed to AI developers. But also, most importantly, even though it was a lower key event and something which was more of an embryo of what could be, let's say, an innovation hub, I would say an innovation testbed for AI developers, we've been doing the IDEAT event, right, where the concept was the following, right? We contributed a RIG platform, and we allow, I think, 10 companies to come and develop apps on the RIG platform with some simulated data on the energy saving use case. And the interesting part was that these companies, they were all coming from different horizons, not only from the telecom world. And I think that's also key to, I mean, for me, that was also a realization that when you put the right tools and the right data in the hands of a very diverse innovation community, you can get to very concrete results and very innovative and enriching exchange between the academic world, people knowing telecom. And we came to very quickly in the form of this hackathon to some also very concrete results and ideas that I hope are just a first step into something more, let's say, long-lasting, if I may say.
Brilliant. Finally, Xenophon, tell us about your experience of working with the AI team in the Edinburgh University with Mahesh Marina, who's not here today, but with his team. Can you share that with everyone, please?
So I'm part of Microsoft Azure for Operators, which is the division of Azure that focuses on telcos. And specifically, I'm part of the office of the CTO, and our role there is to explore new directions and technologies that actually seem promising, evaluate them, incubate them, and eventually graduate them into production if they turn out to be good. And my area of expertise is the radio access network, so the focus of the work that we've been doing is in the RAN and specifically in the Open RAN. And so in terms of the DCIT projects, the first project that we worked on, it's a bit of a mouthful, the name, it was maybe not the best name we could have picked, but hopefully it's descriptive because it is about an AI enabled and secure carrier grade Open RAN platform, which the idea is basically how can you go from this vision of an Open RAN to turn this into a reality that you can see, tangible results. And this project, the partners were Intel, Capgemini, and the University of Edinburgh. And the high-level idea of the project is that we built a solution to demonstrate, first of all, how can you do automation for Open RAN? How can you go from just a bare metal server to deploying a full RAN that is fully operational with just a click of a button? But then going beyond that, how can you add value for operators, whether that is in the form of enabling new use cases or figuring out ways and introducing services that can help them reduce their CapEx and OpEx. And so as part of that, we developed technologies that rely on analytics for the RAN. We heard a lot about the data and how important the data is for doing that. But we discovered that there are a lot of challenges in actually getting that data, and this is part of where we focused in this first project. And then moving from there, we have a follow-up project which is called Perceptron. We were better with the name, I think, for this one. And the idea there is, okay, you might have the data, but actually how, you heard before how important it is to have the right data to solve a problem. So you can build the best ML, you can do the best models you can find, but if you don't have the right data, you won't be able to do much. So there, what we wanted to do is figure out ways of actually going one step beyond and providing an environment where you could actually find that data, collect that data, and use that to evaluate with high fidelity the solutions that you're building. So that's the idea.
Sounds good. Very interesting choice of names as well towards AI, and I'm just hoping that we've we've moved towards that AI, and here we are talking about the projects which have been completed under the Future RAN competition, which was kind of kickstarted 2 years back, and so it's no longer Future RAN. It's there today, the AI part of it. In terms of challenges, we've had many debates during the course of the project. Maria, do you want to tell us a little bit about some of the challenges you faced during the project? And we're not talking GFAs here, though.
Well, yeah, that's a big one. I'm not going to be speaking on Weaver Labs. I'm just speaking on behalf of the entire project and the consortium, because we did work together as one. So I would say that the biggest challenge that we faced in the Aranos project was the readiness of the rig and the ability to expose data from all of the angles. So there were two main challenges. One was the ability, the readiness of the development of those interfaces 2 years ago, right? So most of them were not even defined in standards, and we wanted to create a switching backhaul based on the load on the network. We didn't even have that information coming.
Yeah.
And then there was another challenge, which was more administrative, which was on the early days on the open ecosystem. So there was a lot of difficulty within the ecosystem to share data and information, which hopefully, I must say that nowadays that's kind of like, it's a ridiculous conversation to be having, which is great. But it did cost us quite a lot of challenges to get to the point. It's like, it's open networks. We should be able to share API documentation. But then, I mean, with the incredible effort from the team of University of Bristol and Parallel Wireless, we were able to circumvent all of those challenges and actually pull the data that we needed directly from the RAN in itself. And obviously the models that the university created, they showed then the ability to, switch the backhaul. And that, from our Weaver Labs perspective, what it helped us was to understand the importance of the observability and grabbing all of that data, not only from one single point of the network, but from everywhere else. Because sometimes a decision that is made in the network, it is a combination of different parameters and multiple, different layers. It's cross-stack, right? And because we sit in the orchestration layer, we do have the visibility across the stack. So that really helped us evolve our product in a way that we can actually help solve those challenges if and when they come again. Mm-hmm. So they are challenges, but obviously that's what we're exposing ourselves in the form of these projects. It's good that we face them, because then that means that our products evolve in a much better way towards solving those problems. And also we were able to solve the problem and show that a network with intelligence can be far more optimal than one without.
Mm-hmm. And this is music to my ears, because at DCIT, when we fund a project, we just don't look at how successful that project is. We also look at the challenges which you've gone through in those 2 years. And some of my policy colleagues who are here now working for operators, who put in the policies. It's food for thought for them to put in, and some of my other policy colleagues who are here, it's food for them to kind of work on for the next set of competition which DCIT would launch. So really, really good to hear that. Arnold, your challenges were a bit different, isn't it, in terms of the collection of that data itself, the field data compared to what you get from the digital twins and things like that. Yeah. Could you just elaborate and let the audience know about
certainly.
those challenges?
To me, I mean, obviously, as you say, there are multiple challenges, and that's also the learning of these projects. So I think that's always interesting. I would maybe mention two of them, right? I mean, the first one, which I think was also solved during the project, is the whole process of how do you create a DevOps process for AI app development, moving from a simulated environment to a real test bed environment. I think that's, I mean, we've learned as we were going, and we made good progress in terms of developing that DevOps process with the partners with whom we were involved, like Amdocs and Viavi, for instance. So that was one of the first challenge to overcome, staging platform, development platform, and production platform, and how to make sure that this can flow through continuously. The second one, as you mentioned, is indeed the access to data. I think there's certainly a lot of interesting use cases that people can think of, but at the end of the day, I would say the critical path is certainly the availability of the, let's say, of the RAN vendors community to expose the right data to fulfill these use cases, right? I think when we look at the use case that TIP-RIA, for instance, put forward, very interesting, but not a lot of them can be implemented today given the state of the CUDU-RU community, right? So I think we've been trying to showcase what we could do, let's say, with this test bed, and also having, let's say, one foot as a RAN software developer and a RIG platform vendor was also helping that, to be able to kind of come up to some kind of pragmatic AI, right? In terms of saying, okay, what is the use case? What do we need to expose? And how can we then make it available to a developer so that he can implement a concrete app? So I think that's a work in progress, and I hope that's something that we will also be able to tackle in the context of this new project in Liverpool that we are involved in together.
Sounds good. Zenfone, your Towards AI project went very smoothly, and we're nearing the completion of the project now. And would you like to share some of the minor challenges which you faced in there?
Yeah, I guess I'll speak about one challenge because I think this was maybe one of the biggest achievements we got out of the project, which is it's a similar challenge as was described by the others, which is how can you get the right data for your application from the RAN. And we've seen that there's a lot of work happening in the RIG space, and you can create those great applications, but if those applications don't have data, they cannot do anything. And the problem there is that the way that we observe that data is exposed at the moment for users is on a use case basis. You come up with your application, you say what kind of data you want, then you have to go and convince all the vendors to expose an API to give you that data. And if you only had 2 or 3 applications forever in the RAN, that's fine, but that doesn't scale, obviously. And therefore, if you want to introduce the scale, you have to come up with a different solution. So basically, a big part of our project focused on exactly that, creating a new way of getting data out of the RAN functions, where we basically, at a very high level, the idea is that we allow third-party vendors to inject their own little pieces of code in the RAN functions of vendors in a very safe and provably protected way, so that they can actually tap into the raw data that the RAN functions provide, and then using that little piece of code, they can modify and extract the data they actually need for the project. So in a way, we allow third parties to define their own APIs and get the data out of the RAN functions. And we actually built this, and we integrated this with the functions of several vendors. We integrated this with functions from Intel, from Capgemini, and some other major vendors. And generally, we saw that this is something that was very positively received because actually it solves a problem there.
Sure. And I'm just thinking that so what's next? I mean, are you guys, Microsoft, doing anything with any of the operators at the moment? How do you see the demand side catching up with AI?
Yeah, I think this is something that's very exciting and promising generally. We have all the technology that we built, both the solution but also use cases on top of that, ML-based solutions there. We actually have trialed with several major telcos, both in the US and in Europe. And the feedback is generally very positive on that. Obviously, there's a lot of work to be done yet. This is not, a done deal. But I think, there is a lot of promise to do very interesting things there.
Watch out for a blog post coming out very soon from DCIT as well on that topic from Microsoft. Very quickly, Arnold, yourself, what's the next step, from ARI 5G?
Well, I think there's other projects coming our way, right?
Sure.
I think we mentioned the one in Liverpool, which is going to be, I think, the next stage in terms of bringing these applications in the real world, right? This is an HDD environment. I mean, we're going to have more live traffic, so that's going to be a real test, I think, for some of these use cases and some of these applications. But also next to that, I think is keep on evangelizing, let's say the open run open data, so that
you had an operator in your consortia as well, which is good to see. Maria, quickly, next steps.
Well, I mean, today we are part of Reason, and I think and there is a stand out somewhere around here about the project and down. Sorry, I'm really bad with directions. And there you can talk to the guys and they can tell you all about it. We have an entire work package looking at how can we actually grab that data and give it to the knowledge plane that it's then going to act on that data. And actually, we are bringing a demo into Mobile World Congress showing the whole monitoring mechanism. And that monitoring mechanism is highly innovative in the way that it decides about the data cross-stack as well. And it is using a novel messaging system as well, which, because I fundamentally agree with you, Xenophon, we need to use better tools and microservice architectures, messaging systems, better monitoring architectures are necessary. So that's an incredible piece of work that it's done collaboratively in Work Package 3 in Reason. And obviously as part of the Liverpool project, what we want to see is university students grabbing, the platform and saying, this is our app. And we know nothing about telecoms, but that's fine.
Well, that's good. And it's also a challenge for us as a country to actually retain some of those talents from the university. And there's a whole lot who've worked with yourself as well from Bristol and from Edinburgh who've contributed to the development of AI in telecoms. And we just hope that they keep continuing here and contributing to the economy of this country. And that's the challenge we face today. So I think we're good. We've spoken about the real world projects which these experts have all run. So excellent work, and I look forward to working with you in the next set of projects.
Likewise. Thank you.
Brilliant.